Hi, welcome to the Intro Stats lecture series. And this is our lecture number 5. We are still in the unit testing hypothesis. So in this lecture, we're going to take a look how do we test two population proportions. Okay, so from the lecture number 4, we did a test for the one population proportions. So like in the lecture number 4, we test if you said, hey, for this population, what is the proportion for certain things that you are interested in? So for example, we said, what is the population's, the percentage of the smoker? Is the smoker is 35% for the whole populations? So that's why we test one population, right? So we say P is equal to the 35%. So now for this lecture, we're going to talk about the two population proportions. So if you are comparing, like for example, two cities, and the city A's smokers percentage and the city B, the smokers percentages, right? So now you have a two population and you have a two percentage you want to compare. So that's what is we talk about in the lecture number 5 is to take a look at how do we do the two population proportion. It's very similar like the one population proportion. We still use we call it the z-test. Okay, so now let's go ahead and go to our lecture notes. All right. Okay, so let's take a look at this is lecture number 5, right? So we are going to take a look at the hypothesis testing for the, the two population proportion z-test. So the first thing is here. So what is our hypothesis will looks like? The hypothesis we can write is like, I think the first population, the percentage or proportion, I say is P1 is equal to what? Is equal to P2. So here, that means these two populations have the same proportion, or sometimes you will write this one is P1 minus P2 is equal to what? Is equal to zeros here. That means you say these two has no differences here, right? So the same way we have three alternative hypotheses, like the one population proportion. So what is our alternative hypothesis here? That means the first one, you will say P1 greater than, well, let's do the not equal first. So how about that? Okay, so you can say P1 is not equal to P2, right? That means these two cities, their percent of the smokers are different. Okay, so or you can say P1 minus P2 is not equal to zeros, right? So you can write it a different way. So you can say it's a P1 minus P2 not equal to 0. So either one, so you can say the P1 not equal to P2 or P1 minus P2 not equal to 0. As always, we have, this is a two side, we have one side, we can say P1 is greater than P2. Or if you want, you can write it as P1 minus P2 is greater than 0 here. Or you can say this is P1. Okay, so or you can say this is the P1 minus P2. P1 greater, I'm sorry here. So this will be P1, okay, less than P2, right? Or you can say it's P1 minus P2 is less than zeros here, right? So this is similar. So like this is the right. So we call this type of test, this one's here. We call this is the right hand or right side, right? And the P1 is less than here. We say this is left hand side, one side test, right? So this is left hand side. Okay, so it's just like we say here, then you're looking for your critical values on this side. And for this one side, So for this one side, you are looking for over here, right? So you have this is the one side, and now the same way, so for here, this is the two side, and then you are looking for both end, right? So could it be over here or could it be over here, right? So that's what is very, very similar, like our one population proportion test. You can have, three alternatives here. Now let's take a look at what is our test statistics here, okay? And in here, we say here, the test statistic we use is this one here, we say Z is equal to, so right now you will have two populations, right? So as a P1 hat minus P2 hat, okay? And then here minus 0, I'm not writing it, just 0, right? So P1 minus P2. And then the buttons here, we call this is the SE. Okay, that's why we said it is SE pool. What it means, the SE pool, in here, we said, you have two population, right? So for the population, number one, you will have an X1 value and N1. Then for the population, number two, you will have X2 and 2s, right? So like the example we say, if you are testing two cities, whether their percentage of the smokers are the same, right? So the city number one, you can take maybe 2,000 people and then see how many are smokers. Then for the city number two, you can take maybe 1,500 and then see how many are smokers, right? So those are the those are the data related to each population. So then remember that, so the P1 hat is just like the X1 and 1, and the P2 hat is like the X2 and 2s here, right? So sometime in the problem, they will give you the P1 hat, they will give you the P2 hat, right? Then you can kind of go back to find the X1 and the X2s for that. And because we are, this is kind of like the important concept, because we are testing P1 equal to the P2s, right? So we are testing P1 equal to the P2s here. So we need to pull this two population together. So that's why we call this the P hat. Okay, so this is the P hat, we call this the pool. And this pool just here will just be N1 plus N2. Then you have X1 plus X2 here. Okay, so then you will have X1 plus X2 here. And let me see here. I can give you them. Let's try to get more space here, right? Okay, so let me see here. All right, so we got a little bit more space here. All right, so that's what we call it is SP pool. Okay, so that means I need to combine because I was, this one's here is since we are, so we need to pool since we are testing the hypothesis H0, the P1 equal P2, right? So because we are testing this hypothesis, so we need to pull that. So after you pull that, what is this SE pool? Okay, so this SE pool, the formula for the SE pool will just be, okay, so this will be SE pool will just be like this. Okay, so here, this will be the P hat pool minus 1 minus P hat pool. Okay, then divided by N1 and the plus P hat pool times 1 minus p hat pool, okay? And then to the N2s here, okay? Then you plug the N1, N2, and back, and you plug, you know, like then you plug this one. So after you calculate, right, so you plug the SE back to here, and you will get your z-test statistics, right? So this is our what? This is our z-test statistics here. And so in fact, you know, like you use the pool, so like the TI-84. Okay, so for the TI-84 calculator, the way they build it in is they used this pool because the TI-84, that's what they assume you are testing P1 equal to the P2. But in general, right, so in general is really not necessary to test. Okay, so in general, you don't have to just test the P1 equal to the P2, right? So you can test like something like this. You say P1 minus P2, I'm testing to see the differences is equal to some special values or not, okay? So like I can say this is a P0 star. So what's that mean? That means you said, hey, CTA, I think a CTA has a higher percentage of the smokers than the CTB. And I think they are 10% higher, okay? So that's why this P0 star is, so the differences you suspect, you know, it will be 10%. So for example, like the candidate, right, for the, you know, in the election day, you said, I think the, you know, the candidate one and the percent support candidate one is bigger than the percent support candidate two. And how much bigger? I think there is differences, about 5% differences, right? So you can test the P0 star. That means you don't have to test zeros here, right? So here you test 0, but in fact you don't have to, right? So you can test, they are different by a percentage. So the same ways here, right? So then your HA, you could have the 3 alternatives. So you said P1 minus P2 is not equal to this percentage, or you can say P1 minus P2 greater than what you suspect. You say it's 5%. I think maybe it's more than 5%, right? Or you can test here, you say P1 minus P2 is less than this percent. Okay, so if you use this ones here, your test statistics still is Z, right? So right now you still have this ones here. And so you still use the P1 hat minus the P2 hat. But now you want to minus out these differences, right? So you minus out the P0 stars here, okay? And then you want to divide by the, what I call is the SE. So this E is not pooled because right now I'm testing, they are different. And the differences here is by a certain number. So the SE pool here, so this is the SE, not pool. Okay, so this is the SE, not pool. Okay, it will be is equal to like this. So you will have a P1 hat, 1 minus P1 hat over N1 plus P2 hat over 1 minus P2 and over the N2s here. So you can use this ones, and but like I said, the TI-84 calculator does not give you the choice for here, you know, if you different by numbers here. All right, so that's why, you know, you will So it's always, treated as the pool, like they are equals here. Right? So for this situation, we rarely use it. So especially in our level for this class, typical, we don't use it. We always treat the hypothesis. We try to test these two populations. They are the same here. Okay, now let's take a look at the critical values here, all right? So for the critical values here, let's see here. So this is the z-test, right? So because of this is the z-test, then the critical value, just like we did for the one tail, the same. So here is our critical value. So as you can see, all right, so as you can see in here for 10%, right? So if your significance level is 10%, and then you will have the three different alternatives, right? So will be the 1.64, 1.28, negative 1.28. So let me try to draw what is the 10%. Let's here kind of refresh your memories, right? So if you don't know how to find the critical values, right? So it's a 10%. All right, so if this is the, okay, so here, okay, so if this is, all right, so let's see here. Okay, so if this is, I'm using 10%, right? So if two side, remember, if two side, we have what? We have two tails, right? So it's either be here or here, right? So then this is my critical value, 1.64. This is negative 1.64 because it's 10%, but in the two tail, so each tail have how many? 5%, right? So here's a 5%. And here's a 5%, right? So that's all the remaining is the same way. And now let's take a look at the one side to the right-hand side, right? So to the right-hand side, that means here, right? To the right-hand side, that means what? I'm going to have this tail, right? So if this is the tail, then this is my critical value. So this is P1. So you go to the table, this is 1.28. Right? So everything's, go into your shaded region. This is what we call the rejection regions, right? Then you will reject, right? So this is what is a rejection region. The same things here. This is we call the rejection region. So because this is, the one tail. So what is the percent here? Is 10%. It takes whole 10% here, right? So the same way, let's do the number 3 here. So what's that mean? So that means here, this is less than, right? If it's less than, that means in here, that means I'm going to have this side, right? So let me color that, right? So if this one's here, so what is your critical value? This is 1.28. So this is also your rejection side, rejection region. So what is the percent here? Also is 10%, right? All right, so that is kind of like the refresh our memory about what we learned in the one population proportion. So it's the same, right? So you use we call this Z table and the critical value. So it depends on your critical value. So you compare. So which value, if you guys still remember which value we used to compare, you compare, right? So you compare your test statistic. You compare your test statistic value. In here, we call it the Z value, right? To the critical value. To see if the Z value lands in the rejection region. Okay, that's what we did for the one proportion, right? One population proportion test. Okay, so now the next things here we're going to talk about is how to. So remember, we said the best one is to find the p-values, right? Because, you know, the p-value, you really can tell the people really how significant, you know, how significant the test is. But we know the p-value require the technology to help us. It's not to say you can calculate that, right? So for the test statistic, you can calculate that and then compare to the table of the critical values. But so how do we calculate the p-value? We're going to use, I'm going to the same way like we did a previous lecture. I'm going to show you how to use the, you know, how to use the TI-84 calculator or the R. And before we go that, I like to use this example. So then we can, you know, I will show you now, we can write it down how to, what type of the function, just try to, you know, refresh your memories here. Okay, let's take a look at the example number 1 here. So we said Great Britain has a great literary tradition that covered centuries. Okay, so we said Britons read more than citizens of any other country. And some Canadians, they think that, you know, they do have a higher percentage of the people than the Britons read. So they did a survey. So they have 86% of the, let's try to highlight it so we know. So this is, we have 86% of the 104 randomly selected Canadians, right? Read at least one book. And then also we have 81% out of 109 the Britons here, right? So based on this condition, can we make the conclusion to let the Canadian read more? All right, so those are the key words, right? So now we said, okay, will they read more, right? So I said, that's the P, right? So I would say PC, that's a Canadian, is equal to the percent of the PB, right? PB is Britain. And I want to test what here? I want to test, this is the PC greater than PB, right? So the Canadian read more than the Britons here. Okay, so now let's try to, you know, put all this number. So for the Canadians here, the survey we did N is equal to 1004. And it does not, it didn't, you know, I did not have the X1, but they give me the P1 hat. The P1 hat is what? The P1 hat is 86%, right? So it's a 0.86. Then I need to do the backward to find a, okay, so let me put it here closer so I have a space. Okay, so this is the P1 hat is a 0.86. And then now I need to go backward to find X1. So how do you find the X1s here? So the X1 will just basically is a 0.86 times 1004, and you will get, and then you round it, right? So you will get about 863 people, right? So this is X1. Then the Britons here. Okay, so the N is equal to what? 1009. And the P2 hat is what? Or is a P1C. All right, let's put match the notations here is 0.81. So the X, so this is N1, this is N2, right? So then the X2 will just basically is 0.81 now, right? So it will just be 0.81 times 1009. Then you round it. So you will get about 817 people here. Okay, so now let's take a look at the test statistic. So remember, because we are testing what? they are equals, right? So we need to pull. Okay, so let's take a look at the first here. So let's say the P hat, I have to pull. How do I do P hat pull? You add x1 and x2. So it's A63 plus A17. Then the bottom is N1 plus N2. So it's 1004 plus 1009, right? And now you can, you can get a number for the P hat here, right? So let's take a look at what we have. So A63 plus A17 divided by 1004 plus 1009. And you will get, this is like a point A3. So this is point A3, 4575, something like that, 4575, right? Okay, so now after you do that, you'll be able to calculate the standard error of a pool. Also remember that a big formulas, right? So, okay, so don't get scared. It's not too bad, right? So I will have this is the pointer A3, 4575 times 1 minus the pointer A3, 4575. Then divide by the first number 1004, then plus, okay, then plus the pointer A34575 times 1 minus pointer A34575, right? And then the whole thing's here divided by 1009. Whoa, that's so you need to be very careful about when you use the calculator, when you put those number in there, right? So you need to be very careful here. So I have here, okay, so I put it into the calculator, and I got is point A3. What do I have here? The pools. Okay, so the pools here. Okay, so you basically, I did not get this. So you calculate this one, and then you put on your z-test statistics, right? So your z-test will just be the P1 minus P. So you will have a pointer A6 minus a pointer A1. Then you put this big number, whatever you get here, in here. And now you will be able to get your test statistic. Let's see what is the test statistic, okay? So if I do that, I got is 3.01. Okay, so this looks very complicated, right? So that is why the TI calculator become handy here, okay? So now I'm going to show you, because now we also need to find the p-values here, right? So now I'm on, so in here, like we said, the p-value require the, the technologies to help, right? So let's go to take a look. How do I input this big calculation into the TI calculator? And then you said, wow, that's really very handy here. All right, so now here, take a look here, right? Okay, so let me see here. I think, okay, so I don't, okay, yeah, okay. So I thought I did not share the calculator. Now I shared it, okay? So here you do the first step, of course, you turn that on, then you go to stat, okay? Then after you go to stat, you scoot over to the test. Okay, now under the test, you're going down, 1, 2, 3, here, look here. This is a 2 proportion z-test. All right, then you hit enter. Now you input. So x1, you input like we just calculated A63. So 1004, that's the Canadian the total people they surveyed. Now x2 we just did is A17, N2 is 1009. Now your hypothesis, right? Your alternative hypothesis is P1 greater than P2. That's a, the percent of the Canadian greater than the percent of Britain, right? So you do like this. So you input that, and then you do a calculate, right? Here, you got it, right? So here, that's what is you calculate here. And now let's take a look here, right? So this is your Z. Hey, this is your test statistic, 3.009. And be very careful. There are few things very common. There's so many P's here, right? So this is the values, right? So this is the value. Okay, so this P, the right directly under it, this is my P value. Okay, so my P value is 0.0013. You get that? All right, so this is my P value, 0.0013. All right, and then in the bottom two, right? So, and the bottom two here, so you will get this two. This is a P1 hat. This is a P2 hat, right? So this is the percent of a Canadian. So this is the what? This is A63 over 1004, right? So those are the percentage. So this one P hat here, be careful. So this one's the P hat. Let me use a different color. Okay, this P hat here, right? This is my P hat pool. That means I combine that. That's why in my, you will see, that's what I have at A3, 4, 5, 7, 5. So be very careful. They have so many P value, be very careful, right? So the Z value, this is not easy to confuse. So this value P, this is what we call it, the P value for your test statistic. Then all the other are related to your sample. You see a hat, right? So P1 hat, P2 hat, and the P hat. P hat is the pool. All right, okay, that's good. All right, so now let's go back to our worksheets here. Now the worksheets here. Okay, so what did we just find out are our p-values here? Well, p-values here is 0.0013. It's very small, right? So what is our decisions here? We reject non-hypothesis here. So what's that mean? You will say the data provide significant evidence that percent of a Canadian reader is more than the Britain readers. The percent. Yeah, so that's what we need. So this is from TI 84. So let's go back here. So let's try to write it so you will not forget about it. So what is the TI 84? So function. First, you go to stat, right? Ooh. So this is a stat. Okay, so this is so you go to stat. Then what do you progress into? You progress into test, right? After you go to the test, what is the next things you need to do? So the next things you need to do, you said that you go to the two proportion Z test. right? So then so you just need to input and you don't need to do all this calculation. Probably when you put it into the calculator, you probably, special this SE things is very, special this SE things is very long, right? So you will not make mistakes for that. Okay, so now let's take a look at the R. The R input is pretty easy also. And so let me, I need to put out the R's here first. Okay, so now let's go ahead to go to the my R. Okay, so the reason, so this is how do we write the same things here, right? So like this is the one we did for the, like the previous lectures here. So things here, take a look here, right? So you give the, so this ones here, everybody can give a different names, right? So I say it's results here, right? And you can say it's John or Mary's results. So right now you have two proportion. So basically you just say the X is the count, A63 and A17. That's what we derive it from the percentage they give us. Then N you say is equal to the count C, 1004, 1009. Alternatives, you say it's greater than because it's P1 greater than P2. Of course, the other one you can say is two dot-sided or is less, right? So you can find the different, so these things need to change if you're doing two-sided or it's lessness here. All right, so remember that's the same code. So after that, and then you can just, okay, just run it. After you run it, right, so remember, so you can just do the, oops. Okay, so, okay, let's run this one. Okay, so we run that. All right, so here, now you just type the results. See here, now here's the results here. And so from here, you'll be able to take a look, see here. So like we talked before last time, instead of use Z and R give you chi-squares, right? And then they are tell you are testing greater than, and then the p-values here is a little bit different than the TI-84 calculators, is because they don't pool. All right, so the R, the R does not do the pool, but really does not matter. All right, the differences is very minimal. And so this is 0.0015, and we got it from TI calculator is 0.0013. So you reach the same conclusions here. All right. Okay, so that's good. So let's go back to our lecture notes. Okay, so now let's see. Okay, so let's try to put the let's try to put the code in here so you will remember, right? So for the R's here, and okay, so for the R, I will just okay, so here, let's do here. Oops. Okay, so okay, so now I will just do here. Here, okay, got it, right? So this is what is my R code here, right? So let me see, I can color that to the blue, then it's better for you to visualize it, right? Okay, so now if you want, that's what the two things here. If you want to use the TI calculator, you can use the TI calculator, or if you want to use the the software, so this is the R code, and you can, it's very simple, it's one lines, right? You can get the same test results. All right, that's it. That is for this lecture for the two population proportion. Like we talked before. Okay, so let's try to capture what we did. So the basically is the same things here, right? So you try to test the two population proportion, are they different? So we always have the like three different alternatives, right? So your null hypothesis they equal. So in here, because they equal, there's a little bit of extra step. So when you try to do the test statistics, so the test statistics here is a little bit different, right? So the test statistics is in here, right? So the only thing you need to be careful is you need to do the pool SE. So this is the big formula. And if you feel this is a little too much, and then you can use your calculator to help you here, all right? So then we also set a pool and another pools, right? So here, right? So you have the pool and another pool, and then for the critical value, it's the same way. You have three different alternatives, and then you have a different values. So this is the table you can use. All right, that's it. And then after this lecture, before we go to the next test, because we have talked about this z-test a lot. All right, so we're going to take a detour and we're going to talk about what is this z. All right, what is this z table? What is this nice graph I'm doing here, right? So what is those curves and how do I get those 1.64, 1.28? So we're going to take a detour from here. We're going to talk about what is z distributions. Then we're going back and try to do a little bit more test hypothesis. We're going to test the average of the populations now, okay? After we take the detour to understand what is the z-table. All right, that's it. And a nice talk to you. And looking forward to go to the next lectures here. Okay, bye. Have a good day, okay?